compilation is fine right now. So again, the whole thing starts .map. So that's my message which came from use case saying my sign up was successful. So some of the things which are going to change here is dispatch q.global. In background we were making that call to the interactor in the background, and once that was completed we were using dispatching it in the main thread to update the view. So those things which were happening are going to change right now. We don't do the dispatch queue global regular block way in Rx. Instead we can get rid of all this and then do it in a different way, which I'm going to show you. I'm going to get rid of these first step, which is happening as soon as the sign up button click happens. It comes to the sign up from the view controller presenter. There is a validate step. After that the sign up step happens. So this is something we are going to replace with Rx version, which is going to be very interesting, and we'll do that in a bit. But before that, you're doing a sign up here. Sign up is where it comes. You make a call to the use case, which is the interactor, and then do the sign up. You get a response message and then you start handling that. So whatever we were doing, that is, we were getting that message here and then we were updating the status using a view model to update, and then if it is successful we were routing this to the next logins, back to the login screen. That's what was happening. In case of a failure, we were updating again with an update failure message, and then we were doing a progress, stopping the progress, which was like blocking the button from once you're hitting the sign up button, we were making it as signing up and then stopping any more clicks to happen, because already a request is in progress. Once that request is completed, we update it back to is completed state, where we will reset it to enable state. That is what it was happening here. Same things we are going to do the Rx way here now. So you have these things. This is map is my success case. Let's do that. So this is my success case, and on success this has to run. Okay, these things we'll take care in a bit. Let it run in the main thread for the time being, but I'm gonna move everything to the background thread. So on success, these many steps were happening. So we don't do these. So whatever was here is like we were waiting for 2 seconds after the success to route it to the login view. So we can take care of that in a different way in Rx. Let this be here. So on success, I received this message. I'm just passing it to this up to update the view model. So let's keep all things here, weak self, so that success part is happening here. This is not in no way complete, but I'm just showing you, at least make it the workable way. And this request happened and then response happened. Now I'm gonna introduce something. Right now, if I had to make it like this, subscribe it in the whatever thread it is running in. Like right now it is in the main thread. I can directly make this call because it is coming from the user interface. It will make this call, and it will make this call in the main thread itself, give a response, and we are handling it in the main thread itself and routing it to the next screen if it is successful. And we then need to call this is what will make this code to work. You'll have to subscribe to this. Sign up is an observable, so you need to subscribe it somewhere so that this mapping will work. And then after that you need to add it to a dispose pack, so that if this objects needs to be, if this observable needs to be deallocated, we added to something called as a dispose bag. So let's define that dispose bag here. It's like a garbage bag where it keeps collecting each and every uh, disposable observable objects. So this is a bag which we create and keep wherever we create one bag, and then add each and every observable which needs to be deallocated once the purpose of this presenter is completed, or any layer which is using it. So this is how you use Rx version. This is my observable. Subscription happens here, and this is where it gets observed. Wherever you map or subscribe, this is where it gets observed, and then you're adding it to the dispose bag. So this part is done right now. So it is going to behave in a regular way right now, where everything is running in the main thread. Suppose, let's say, if I had to dispatch something in the background thread, there are different ways of doing it. Like if I had to call subscribe on concurrent scheduler dot quality of service background thread. So even before that, let's see how it is going to behave. So we don't have any errors right now. I just want to show you what happens if something is, whether something is running in the main thread or the background thread. So let's go to this use case. This is my interactor, and let me just print sign up running thread is main thread. So I'm just asking whether it is running in the main thread or not. So we can just run that and see now. So app is running fine. Go to the sign up screen. Everything is wired. So it's coming to this sign up screen, doing this sign up function. It should now be running in the main thread because it's coming from the UI. We are not dispatched into anywhere else. So once you do, let's say I'll just use something existing so that it does not navigate to any other screen. wish@gmail.com is something, some password. No. Rerun this. Sign up. Hello. wish@gmail.com. This is the existing one. It's not going to show me any error messages because I have not wired anything. It's going to give me an error, but I'm interested in seeing in which thread it is running right now. So I do a sign up. So it says sign up is running in the main thread. Yes. It failed with 401 because this email ID is already existing in my database. So now it says it's running in the main thread, which is not a great thing to do. So let's change. How do we change and make this run in the background thread? I'll do subscribe on. So this will make sure that whatever is the creator is running in the background thread. So I'll call the concurrent dispatch queue.init in the background. So at least this creator part where the observer is getting created, that's where the subscribe on needs to get called. If you had to run this map in a different thread, then you will have to call the observer, which is whatever is observing for changes, if that needs to be run in a different thread, then you call observe on. Or whatever where the subscription is getting created or the subscriber is getting created, this is the sign up function where you're creating that single. If it needs to run in a different thread, you call subscribe on. So this, at least this presenter now will be running in the main thread. And let's do that. Print sign up presenter is in main thread. We just call checking here also what all things are running in the main thread and which is running right now. This is supposed to be running in the background thread. So go here, name, hello, wish@gmail.com, test 1 2 3 4, sign up. So sign up running in the main thread, true. Okay, so subscription did not work. It's still in the background, it's in the main thread. We go here, sign up interactor, observe on, let's see that. Still everything is the main thread. So this creation part did not work. So let's go to sign up and check here. Hello. Still things are in main thread. So let's keep working on it. This is anyway, we know that it's in the main thread. Whatever we need to do is move this to the background thread. These things did not work for it because creation is happening somewhere else. That has to be run in the proper thread. So we'll come back to that in a bit. I'll show you at least this part is right now working through Rx subscription. So now we are going to introduce something here because we know that all the UI things has to run in the main thread. At least let's say this update and then route to a new navigation screen, at least these things has to happen in the main thread. So whatever is coming back as a response from the presenter, the UI, that all things has to work in the main thread. And something like the sign up which needs to happen is more like a API call to the server, should be happening in the background thread. So to make sure that everything is and some things like UI thread should not be at least updates to UI should not end at all. So let's say I keep tapping on a button and then if that tap stops happening because of the subscription got disposed, then that will not work out for a UI element. For that, instead of this observable, there is something called a UI trait called a driver, which is available, which can be replaced. So after this process is completed, if I have to convert it into something which does not error out, which always remains in the main thread, and also which gives you a replay like the last state which was maintained in it. So for that there is something available called as a driver. So we can modify this and map this as something called as a driver. Again, I don't know what this sign up primitive trait, it is coming as part of RxCocoa. Come back here as driver. So this is where the error handling can happen. So if there is an error coming from this signal, I can always capture it here, and then this is now converted to something called as a driver object, which is nothing but an observable which will never error out, which will always make sure that it will run in the main thread, and it will always gives you a replay value of 1, like at least last value will always be replaced, value will be replayed back to you. So that's how this is going to work. So now this will let you do a drive instead of subscribe. So I already have an error here, so I know the error is going to come back as guard let error. I know it is going to come back as sign up error, so I can always cast it to sign up error. Else maybe I'll just return. I don't do anything. Non-return type. So this sign up error is going to give me a message str. Driver dot it never I can call, so that it does not error out, and again return dot never. So this is where the error handling is going to happen. Why is it give me? Okay, this is going to be of type dot error of str. That's what I meant. Case, because it's an enum. This error sign up error is an enum type of type error. If I receive, I get a value out of it, like what is the error which was received. So sign up error is my type, and then I can use that to show the other part of the failure case. Like here it is, when it failed, I'm just updating the status using a view model with those error values. I can just grab that error case. The presenter. View. So again I can pass weak self here, self error, this is going to be str. So that is my error case. So those two things can happen when error or success can happen, which again I'll have to move it to the other thing, which is I can stop the completed state. So I can also do that. The update on complete, that can happen at these two places. So once it is successful, I'll say update is completed, or if it is a failure also, I say update is completed. So the starting of the update is happening in this valid case, which we will again modify later. So this is my, so this whole thing is captured right now, the success and the error cases. I'm just gonna end this. So let's see if it shows me. So right now everything is in the main thread. We need to move it to the background. We'll do that. Before that, let me just show you whether at least this bit of the code is working or not, because we have moved some bit of the code to Rx. So still a little bit is still left in the UI side, which needs to now move to the non-Rx case, to the Rx case right now. Sign up. Hello. Wish. It should give me an error message. What is this? Yeah, so this update happened and it disappeared as well. Okay, that can also be okay. The disappearance is that it disappeared because we already have a code in our in this state update progress, or at least update status, where after 2 seconds I'm making that status disappear. That code is still there, so it disappeared. This is all non-Rx version, but at least until the the presenter side to this service layer and to up till the parser, we have the Rx version integrated here. So everything is still running in the main thread. We'll start moving into the background thread as well. These calls should happen in the background, and this anyway is a driver, so it will take care of the main thread things. So at least this bit of series, first bit of episode is right now completed. I'm coming back with the next episode where we will start moving the UI things towards the Rx side and then start making it work and end to end using Rx, from starting from the request until the response. Everything is going to happen using Rx, and even the dispatch queue is going to work in a way where things which has to happen in the background will work in the background, and things which has to work in the main thread will happen in the main thread. So until the next episode, keep watching and learning whatever bit I have already done with. So until the next episode, it's bye from me.